All right, now we're going to learn how to balance chemical equations. This is where this chapter gets a little more complicated. It's not hard, but it's a skill that a lot of students can struggle with. So I'm going to teach you the way that I learned it, and I think it's the easiest way to balance chemical equations. So please, if you're watching the video, follow along with the guided notes, and we'll work a lot of practice problems together. And I think by the end of it, you're going to think it's pretty easy. And I think that balancing chemical equations is one of the funner things to do in chemistry, and it's really not that bad. So anyway, here we go. In this figure, it shows the balanced equation for the reaction between aluminum and bromine. Okay? It gives us this coefficient out in front, this number. You take this coefficient and you times it by the subscript here. What's 2 times 1? 2. So they're showing 2 aluminum atoms. The coefficient here is 3. What's 3 times 2? 6. So we better have 6. 1, 2, 3, 4, 5, 6 bromine atoms. If we react them, how many aluminums do we have in the product side? 2. How many? So there's my aluminum there, and there's the other one, 2. How many bromines? 6. 1, 2, 3, 4, 5, 6. And if you'll notice, we had 2 aluminums on the left. We've got to have 2 aluminums on the right. We had 6 bromines on the left. We've got to have 6 bromines on the right. Okay, and that's what we're going to be doing, is learning how to balance them. Okay, before we start, we've got to know what a coefficient is. In your guided notes, there's a spot for you to write the definition for a coefficient. Coefficient is the number written in front of a reactant or product. It's a number written in front of the reactant or the product. And coefficients are whole numbers, like 2, 3, 4. They're not decimal numbers. We're not going to put 1.5 or 2.3. They are whole numbers. Also, here's this rule again. In chemistry, do we write ones? No, they are implied. So if it's just 1, we leave it blank. And that's an implied 1. Okay. The coefficients in a balanced chemical equation describe the lowest whole number ratio of the amounts of all the reactants and products, and they must be reduced. Okay, the coefficients, this is important, must be reduced. What do I mean by that? What if my coefficients, guys, were 2, 2, and 4? Could that be reduced? Yeah, that's reduced. They're all divisible by 2, so this would be reduced to 1, 1, and 2. What if it was 3, 12, and 12? Could that be reduced? To 1, 4, and 4. So that's what I mean. These coefficients must be reduced. All right. Let's go through the steps that we're going to use to balance. Okay, number 1. Write the skeleton equation for the reaction. We write the skeleton equation for the reaction. Step number 2 is we're going to count the atoms of the elements in the reactant side. So we count them on the reactant side and we total them up. Number 3, we count the atoms of the elements on the product side. We count the product side and we total them up. Number 4, you change the coefficients to make the number of atoms of each element equal on both sides. The reactant side has to equal the product side. Remember the law of conservation of mass? Whatever's on the left, you've got to have that number on the right. And number 5, write the coefficients in their lowest possible ratio. What's another way of saying that? You've got to reduce it. Reduce the coefficients. Step number 6, check your work. What's nice about balancing chemical reactions is that when you're done, you have a way of checking and making sure you know you did it right. How do you check? Well, the numbers of atoms has to be the same on both sides. So if you've got 10 atoms on the left side for reactants, how many are you going to have on the right side? 10. Law of conservation of mass. You can't create nor destroy mass, so it's got to be the same on both sides. Okay, this is a nice flow chart if you're into flow charts and you like looking at them, but I think it'll make sense as we go through some practice problems. Okay, practice problem number 2. It says balance the following chemical reaction. The first thing that I would like you to do, step 1, is to find the arrow. This arrow separates your reactants from the products. Let's draw a line down from that arrow. So find the arrow, draw the line. That's step 1. Step 2 is we're going to list all the elements on the reactant side. I've got hydrogen, so I'm going to put an H for hydrogen. Okay, I've got hydrogen, so I'm going to put H down here. I've got oxygen, so I'm going to put an O right here. Okay, so I listed all the elements on the reactant side. Now I've got to list all the elements on the product side. But guys, listed in the same order. If you've got hydrogen on top, let's keep it on top. If you've got oxygen on the bottom, let's keep it on the bottom. Okay? Next step is we're going to count and total these things up. How many hydrogens do we have right here, guys? 2. This little subscript, that means there's 2 hydrogens. How many oxygens do I have? 2. So I put 2 and 2. Now let's go to the right side, the product side. How many hydrogens do I have? 2. How many oxygens? I have only 1 oxygen. Now, is it balanced? Is it balanced? No. So, what can you do to balance it? What number can you change? Can I just put a little 2 right here, a subscript? No. You can't add subscripts. What number can you change, though? The coefficient. So we're going to add coefficients to make it balanced. Okay? Let's see if we can do that. So I look across, hydrogens are balanced. That's good. Let's go down to oxygens. Are they balanced? No. So what's the lowest number that both 2 and 1 can go into? 2. How can I make 2 oxygens on this side? If I had a coefficient, what coefficient should I put right there? Let's put a 2. Because 2 times 1 is what? It's 2. But did that change my hydrogens? What's 2 times 2 now? That's 4. So now we got to go back and change that to 4. So I balanced my oxygens, but in that process, I have unbalanced the hydrogens. So now I've got to go back to the left side. How could I get 4 hydrogens? I got to put a what as a coefficient here? A 2. Because 2 times 2 is what, guys? 4. Are my hydrogens balanced? So just look straight across. They're balanced. Are my oxygens balanced? Look straight across. They're balanced. Okay, now when you think you're done, so can you reduce a 2, 1, 2? And the answer is what? No. How come? 1 is already as reduced as it can get. So if one thing can't be reduced, one of those coefficients cannot be reduced, you can't reduce any of it. So that's my answer. Okay? That's the balanced chemical equation. Not so bad, is it, guys? Okay, let's go to another one. Practice problem 3. What's step 1? See if you guys can remember it. Find the arrow, draw the line. Our arrow's right here. I want you to draw a line straight down. Let's separate the reactants from the products. Step 2, what are we going to do? List all the elements. I just do it in order. It doesn't really matter what order you put it in here, guys. Hg, which is mercury, is going to go first because it's listed first. Doesn't really matter, though. Then I've got oxygen. Okay. If I have mercury on top, do I have to keep it on top? Yes, that's what I do because it's easier to line it up, to just look straight across. So we have mercury over here, and we also have an oxygen. Okay. Now we go back and we total up the numbers. How many mercuries do I have on the left side? 1. So put a 1 right there. How many oxygens? 1. How many mercuries on the product side? Just 1. How many oxygens? 2. Okay. Now look across. Are my mercuries balanced? They are. Let's go down. The oxygens, are they balanced? They're not. Okay? So, again, let me emphasize this point. Can you add subscripts when you balance chemical equations? No. You can never add subscripts down here. You can only change the number by the number out front, which is called the what? Coefficient. So if I wanted 2 oxygens, what do I have to put here? I have to put a 2 because 2 times 1 is what, guys? 2. But does that mess up my mercuries? Yeah. Yes, it does. How many mercuries do I have now? 2. Now, let's go back to the product side. How do I get 2 mercuries? Put a coefficient of 2 right there, and now I have 2 mercuries. So now let's look across. Are my mercuries balanced? Yes. Are my oxygens? Yes. Can I reduce a 2, 2, 1? No, because 1's already as reduced as it can get. And so there we have it. Okay? I want you guys to try this next one on your own. So if you're watching the video, please try it on your own right now. So hit pause, try it on your own, and see if you can get this one right. Okay, so let's see how you guys did. First step, help me guys, what do you do? Find the arrow, draw the line. That separates the reactants from the products. Step 2, what do? List all the elements. I just do it in order, so if there's an N here, that's nitrogen, I just put an N. Okay? I've got hydrogens, so I'm going to put an H. Let's go to the right side. I'm going to keep it in the same order, so I'm going to put nitrogen on top and hydrogen on the bottom. Okay? Now let's total the numbers up. How many nitrogens do I have on the left side? 2. How many hydrogens? 2. How many nitrogens on the right side? Just 1. How many hydrogens? 3. Okay, now we just look across. Are my nitrogens balanced? No. How do I balance them? I got to have 2 on this side. Well, how do I get 2? Well, we put a coefficient of 2 right there. 2 times 1 is 2. But does that change my hydrogens too? It does. What's 2 times 3? 2 times 3? 6. Yes, 6. Okay, now my nitrogens are good. Let's just continue down. Let's look at the hydrogens. Are they balanced? No. I can't go lower than 6, so I've got to get this side to 6. How can I do that? If I put a coefficient of what right here? 3. Yes, because 3 times 2 is what? 6. And now, is it balanced? Yeah. My nitrogens are balanced, my hydrogens are balanced. Now, ask yourself, can you reduce a 1, 3, and 2? Can't reduce it because 1, low as it goes, and 2 and 3 aren't divisible by each other. So there you go. How many of you guys got that? Raise your hand. Good job. Let's get on to some more difficult problems maybe. Okay, practice problem number 5. Again, I would like you guys to try it on your own. If you're watching the video, try it. So you got to hit pause for a second, try it, and then hit play once you've got your answer down. Okay, let's see how you guys did. First step, help me out. What do? Find the arrow, draw the line. Now let's list the elements. Okay? I just listed in order every time. We've got sodium. What other elements do we have? Hydrogen. What other element? Oxygen. Okay? Now, you can look on this side, but we're going to keep it in the same order anyway. So let's just keep it in the same order. Sodium, hydrogen, and oxygen. The reason I do that is because then you can look straight across and it lines up better. Okay. Now let's total the atoms. How many sodiums do I have, guys? 1. How many hydrogens? 2. How many oxygens? Just 1. On the right side, the product side, how many sodiums? 1. How many hydrogens? Now be careful on this one. We have 1 right here, but then you have 2 over here. So what's 1 plus 2? 3 hydrogens. How many oxygens? Uno. Okay. Now we look across. So start at the top. I just always start at the top. Sodiums, are they balanced? Yes. So let's move on. Hydrogens, are they balanced? They're not balanced. Okay, now you're going to see this a lot. 2 and 3. What's the lowest number that 2 and 3 can go into? 6. So let's try and make it 6 and see if that works. And we'll find out. Okay, so how do I get to 6 on the left side? Times it by 3. Okay, that gets me to 6, but then does it change my oxygen? How many oxygens do I have now? 3. Okay. Now let's try to get to 6 on this side. What do I need? Oh, you know what? That's not going to work, is it, guys? It's not going to work that way. Because if I try to get to 6 on this side, I've got to have an even number here, and this one's even as well. So I don't think it's going to work that way. So, you just trial and error it. Let's see if we can go back. Let me erase this. So that's not going to work. Okay, so this was a 2, right? Let's don't go to 6. You see where the hydrogens are split here? Whatever number I put right here, it's going to be an even number, correct? So I need to make this side an even number. Right now it's 3. What's the next even number I can try and get to? 4. Okay, how can I make my hydrogens 4 here? If I put a 2 right here, now that gives me 2 hydrogens here and 2 hydrogens here. Doesn't that get me to 4? Okay, can I get to 4 on this side? What do I need right here? A 2. So that gets me to 2 times 2 is 4. But how many oxygens do I have now? 2 times 1 is 2. Okay. Okay, now we got to be careful on this side. How many sodiums do we have? Guys, help me out. How many sodiums? 2. 2 times 1 is 2. How many oxygens? 2 times 1 is 2. So whenever you change a coefficient, I just made a mistake. You should always go through and change the rest of them. Okay. So are we balanced, guys? 1 sodium, 2 sodiums. So we're not balanced yet. How do I make 2 sodiums? Put a 2 right there. Now we've got 2 sodiums. So 2 sodiums, 2 sodiums. How many hydrogens? 4 and 2 is 4. And oxygens, 2 and 2. Can I reduce it? 2, 2, 2, 1. Nope. Because the 1 is already reduced as much as it can get. Okay, so that was kind of a difficult one. That was a good one. Okay, practice problem number 6. I want you guys to try it on your own. Please hit pause if you're watching the video and try it, and then once you have an answer, hit play. Okay, let's see how you guys did. Find the arrow, draw the line. Now we list the elements. I just start from the left side. We've got Fe, which is iron. We've got O, which is oxygen. List them in the same order on the right side. Isn't that right, Will?
Yeah.
Okay. Will, how many irons do I have on the left side?
1.
1. Thank you. How many oxygens?
Dos.
Dos. How many irons on the right side?
Dos.
Dos. How many oxygens?
Tres.
Tres. Good job. Will, are my irons balanced?
No.
How do I balance them?
Take one away from the right side.
You can't take away.
I don't know.
You can't take away. That's a good point. You can never take away. You have to add, right?
Yeah.
So let's add to the left side. How can I do that? What do I need as a coefficient right here, Will?
1.
Well, it's already a 1, and it's not balanced.
2.
Dos. What's 2 times 1, Will?
3. 2 times 1 is 2.
2. It's 2. Okay. So my ions are balanced. Let's go to oxygens. Guys, are they balanced? No. 2 and 3 is not balanced. So what's, again, what's the lowest number that 2 and 3 will go into? 6. So let's try and get to 6 on the left side. How do I get to 6 here? If I put a 3, what's 3 times 2? That's 6. Now I need to get to 6 over here. What coefficient do I need right here in order to get to 6 oxygens? A 2, because 2 times 3 is 6. But does that change my ions? The Fe's? Yeah, now how many Fe's do I have? 4. So now we got to go back over here because my oxygens are balanced, but my ions are not balanced. How do I get to 4 here? Yeah, I can't have a 2 there anymore. What do I got to have there? A 4. Now 4 times 1 is 4. Are they balanced now? Yes. Now let's make sure it's reduced. Can I reduce a 4, 3, 2? Nope. So that's my answer.
Does it matter if you start with the oxygen first or the ion
Nope.
first?
Nope. I just always list it from left to right.
But like when you're balancing them out.
Oh, doesn't matter either. But I always just like to start from the top and then go to the bottom. That's kind of what I do. Good question. Okay, let's go to practice problem number 7. I've got, let's see, so 3 more including this one. So here we go. Let's see if you guys can do this one on your own. Please try it. So hit pause, try it. Once you have your answer, hit play and see if you've got it right. Okay, let's see how you did. We find the arrow. Draw the line down. That separates my reactants from my products. Now let's list the elements. I've got aluminum. I've got iron. Notice that I just go from left to right. I don't care the order. Doesn't really matter, but I like to keep it orderly. So, and then oxygen was listed last. I'm going to put it on the bottom. Now, you could look over here and do the same thing, but we have to keep it in the same order. So I'm just going to put aluminum, Fe, and O. Okay, that way I can look straight across and we can balance it very easily. Now help me out with the numbers. How many do I have on the left side? Aluminums. 1. How many irons? 1. How many oxygens? 1. Yeah, all the subscripts here are just 1, so everything's 1. How many aluminums? 2. There's a subscript with 2 there. How many irons? 1. Yeah, be careful. Iron's over here now. And how many oxygens? 3. Okay, now what I do is just start at the top and work myself down. Okay? Work your way down until you get all balanced. Aluminums, are they balanced? No. How do I balance it? What do I need right here? A 2. Coefficient of 2. That's 2 times 1 is 2. Now my aluminums are balanced. So let's go to the next one. Irons, are they already balanced? 1 and 1. Okay, let's move on. Let's go to oxygen. 1 and 3, is it balanced? No. What do I need? What should I put right here to get 3 oxygens? Let's put a 3. 3 times 1 is 3. But does that change my ions as well? Yeah, so don't forget to go back. And now we have 3 ions. So even though we balanced the oxygens, now our ions are not balanced. How do I balance the ions now, guys? I need a 3 right here because 3 times 1 is 3. Is it balanced? Yes. Can I reduce a 2, 3, 1, 3? No. So there's your answer. How many got it right? Nice job. Okay, a couple more. Number 8. Practice problem number 8. So try it. Give it a shot and see if you can get it right on your own. Hit pause and do it by yourself. Once you have an answer, hit play and see if you got it right. Okay, guys, I think this was a pretty easy one, wasn't it? Let's see if you got it right. So we find the arrow, draw the line. That separates my reactants from the products. Okay, I just listed from left to right. I've got potassium and I've got bromine. Okay, I'm going to list it in the same order over here so it lines up. How many, help me out on this. How many potassiums do we have? 1. How many bromines? 2. How many potassiums on the right side? 1. How many bromines? 1. Okay, are my potassiums already balanced? They are. So let's move down to the bromines. Are they balanced? They're not. So how do I balance it? I need a coefficient of 2 right here because 2 times 1 is 2. But does that change my potassium? It does. How many potassiums do I have? 2. Now, my bromines are good, but I got to go back up here to the potassium. How do I get 2 potassiums on the left side? Coefficient of 2 right there, and now it's balanced. Can I reduce a 2, 1, 2? No, you can't. So there's your answer. How many got it right? Good job. Okay, I've got one final one, and it's a good one. Okay? Try this one. This is a little bit more complicated, but I think you guys can do it. Okay, if you're watching the video, please try it. So hit pause, see if you can get it right, then hit play. Okay, guys, let's see if you did this correctly. Find the arrow, draw the line. I just list them in order. So I've got carbon, I've got hydrogen, and I've got oxygen. Keep it the same. C, H, O. Help me out, let's go fast. How many carbons on this side? 7. How many hydrogens? 16. How many oxygens? 2. Hey, we're not done. Don't put yourself away yet. Help me out. How many carbons? 1. How many hydrogens? 2. How many oxygens? 3. 2 here and 1 here. That's 3. Okay? Okay, now let's just start at the top. Carbons. How do I balance it? Well, I need 7 as a coefficient. That gives me 7 carbons, but how many oxygens now? 14 plus 1 is what? What's 14 plus 1, guys? 15. Okay? Now let's go to the hydrogens. How do I get to 16 on the right side? I better have 8 right here, right? That gets me to 16, but it does change my oxygen. What's 8 plus 14? 22. How do I get to 22 oxygens on the left side? This has to be an 11. That gets me to 22. Can I reduce now they're all balanced, 7, 16, and 22. Can I reduce a 1, 11, 7, and 8? Can't. Okay. Guys, good job. Hopefully that makes sense. I want to give you some more practice with this. Hey, please, guys. In your student workbook, there is a worksheet. It's called Balancing Chemical Equations Worksheet. I would like you to turn there now. That will give you some more practice on doing these types of questions. And hopefully we learn how to balance chemical equations. They're not that bad. They're actually kind of fun when you get the hang of it. So hope that helps.